Welcome back to our geometry series. Today we are up to section 8.4 where we'll be looking at cones. In our last section we looked at a cylinder, which is two circles that are connected by a surface. What if we eliminated one of those circles and had it just be a point? Well, a 3D object with a circular base and vertex that is not coplanar with the base is called a cone. Similar to a cylinder, we have an axis. Here, it connects the center of the base to the vertex point. If the axis happens to be perpendicular to the base, it creates a right circular cone. The distance from this circle to the vertex on a circular cone is the slant height. The perpendicular segment joining the base and the vertex is called the altitude, whose length is the height of the cone. So for a right cone, the axis and the altitude are the same thing. So if we take a look at an oblique cone like this, you can see that the altitude, while still being perpendicular to the base, is now different than the axis. The axis still connects the center of the circle to the vertex. Next, let's look at the lateral surface. This would be the cone part of an ice cream cone, the part that you would eat. Next, let's specify that this is a right cone by showing the axis being perpendicular to the base. And that leads us to Theorem 98. The lateral area, L, of a right circular cone is 1/2 the product of the circumference, C, and the slant height, L, lowercase l. So in other words, L equals 1/2 C times the other L, lowercase l. So let's add some numbers to our figure here. We're now showing that the radius of the circle is 5 and the slant height is 10. So we can rewrite the formula like this. L equals 0.5 times 2 pi r, which is the circumference of the circle, times lowercase l. Since the radius is 5, that term becomes 10 pi, and lowercase l becomes 10. We can multiply all those together to get 50 pi. And for the sake of simplicity, we'll leave it in the terms of pi instead of multiplying 50 times 3.14159 and so forth. So let's park that information up here and look at Theorem 99. The total area T of a right circular cone is the sum of the lateral area L and the area of the base, B. So T equals L plus B. Well, we already know L, we just found that. L is 50 pi. And the area of the circle is pi r squared. So we can replace B with pi r squared. The radius is 5. 5 squared is 25, so we can rewrite that term as 25 pi. We're left with 50 pi plus 25 pi gives us 75 pi. For our next example, we can see here that the height of the cone is 9 and the radius of the circle base is 4. We'll ask this question. What is the volume of this cone? How much ice cream could you fit inside the cone right up to the rim of the circle? And that leads us to Theorem 100. The volume, V, of a cone is 1/3 the product of the area of the base, B, and the height, H. So we can rewrite that as volume equals 1/3 base times height. So we can substitute in those values. The area of the base is pi r squared, so we can substitute in those values. The area of the base, pi r squared, is 16 pi, and the value of the height is 9. If we multiply all that together, we end up with 48 pi. Remember, if a problem is showing distances, say, in centimeters, then the volume would be in cubic centimeters. Let's jump over the whiteboard and do some examples.
They were cones!
All right, we're going to try to draw a cone. We'll go way up here, and we're going to come down and come down, maybe make it a little bigger. And then here's kind of the back side of the circle, and here's the front side of the circle. That's not very good. And we're going to say this is a right cone. So here is the altitude and the axis, same thing. Here's a radius, here's our little right angle square. Let's say the height is 4, and the radius is 3. All right, we're going to find the lateral area, the total area, and the volume of this cone. And we'll kind of jot down here that the lateral area is equal to 1/2 circumference times the slant height as a lowercase l. And we know that the total area is equal to the lateral area plus the base. And we'll put down here that the volume is equal to 1/3 the base area times the height. So going back to our example, 1/2 the circumference. So it's 1/2 the circumference times the slant height. Well, 1/2 is 1/2. Circumference is 2 pi r. And, well, what's the slant height? Well, it's this distance here. Well, we have a right triangle. The radius, the height, and the slant height make a right triangle. So we can use Pythagoras' theorem, or we know that 3, 4, and 5 make a right triangle. So we can put that in here as 5. It's going to equal to 1/2 2 pi r. What is r? R is 3. So that's 6 pi times 5 is 30 pi. We can barely squeeze this in that the lateral area is 15 pi. All right, so total area is the lateral plus the base. And lateral we just found. That's 15 pi plus the base, which is pi r squared. Pi r squared. R squared is 3 squared, so 9 squared. That's 9 pi. So it's 15 pi plus 9 pi is 24 pi. And finally for volume, it's 1/3 the base area times the height. Now, let's rewrite that as 1/3, because 1/3 is 1/3. Base area we just found as pi r squared. This was that 9 pi. 3 squared is 9 times pi. That's 9 pi times the height. Remember, the height is from the center of the circle here. So this would be 4. Well, 1/3 of 9 pi is 3 pi times 4, or also known as 12 pi. And we're still on the screen, so that's good. All right, let's clean this off and do one more example. All right, this one's going to be a little weird, and I'm going to try to give myself enough space here. I'm going to draw a nice, large cone. It's going to be kind of a weird cone. Here's the back of the circle. Here's the front of the circle. Here's the axis, right? Axis is from the center of the circle to the vertex. It's kind of at an angle. There's the radius. And what I'm going to do is say that this part of the cone and the radius are actually perpendicular to each other this way. Let's say that the radius is 5 and the length of the axis is 13. And all we want to do is find the volume. The volume is 1/3 base area times the height. Well, what's the height of this cone? So in this case, the axis and the altitude are different, and the length of the altitude is the height. The perpendicular segment joining the vertex of the cone to the plane of the base is called altitude. So this altitude is also the height. So we'll just put h for height. Well, that's what we're trying to find. But it turns out we have another right triangle. This side is 5, this is the question mark, and this is 13. Again, we can use good old Pythagoras, but if we happen to know that a 5, 12, 13 is a common right triangle. So we know that this is equal to 12. What about the base? Well, base is pi r squared. So let's just write that out as 1/3 pi times the radius squared. 5, that's a 5, squared times the height, 12. I'm going to simplify a little bit here. 1/3 of 12 is 4, and this is times 25 pi. We end up with a nice happy 100 pi as the volume of this oblique cone. That's it for today. It's a pretty short section. We'll see you next time.